Today, we trust our eyes to inform us about the world around us. But what happens when you're plunged into an environment where your trusted senses deceive you? Where what you see defies logic and reality twists into mind-bending forms? This isn't a jump into the rabbit hole of Wonderland, but a reality much closer to home, hidden within our own perception. This is the captivating realm of optical illusions, a place that challenges your confidence in what you perceive as real. The real magic of these don't lie in the trickery of the images, but in the intricacy of our visual system, painting a picture so captivating that it forces us to question, can we really trust our eyes? Our vision is an incredible marvel of evolution, capable of perceiving millions of colors and fine details. Yet the mechanics behind the magic of sight reside not in our eyes, but in our brain. Our eyes merely act as lenses, capturing light and translating it into electrical signals. These signals then journey through the labyrinth of neural pathways to the brain, which interprets this raw data, constructing the world as we see it. The brain is the master puppeteer behind our perception, pulling the strings of our reality. Optical illusions are like magic tricks for the brain, exploiting the shortcuts and assumptions our brain uses when interpreting visual input. By presenting our eyes with carefully designed images, we can trick the brain into seeing things that may not exist or overlook things that do. They exploit the gaps between perception and reality, manipulating the way we interpret the world around us. For instance, consider literal illusions that use simple lines and shapes to mislead our perception. Take the famed Muller-Lyer illusion, where two identical lines appear to be different lengths because of the direction of the arrowheads at their ends. Despite what our brain insists, the lines are the same length. This illusion reveals the brain's knack for interpreting depth and perspective, influenced by our three-dimensional experiences in a two-dimensional context. Going further, illusions can also provide an understanding of the complex mechanisms behind facial recognition. The Thatcher illusion is an unsettling example. In this illusion, a photograph of the face is turned upside down, with the eyes and mouth also inverted. When you look at the inverted image, everything appears normal. But when you turn the image right side up, the face appears grotesque. This illusion tells us how our brain is tuned to recognize faces in a particular orientation, a trait vital for social interactions. Now let's switch gears to movement. Ever glanced at a static image only to see it crawling, spinning, or pulsating? That's a whole new category of optical illusions, known as motion illusions. A prime example of this is the rotating snakes illusion, created by Akiyoshi Kitaoka, a psychology professor in Japan. In this illusion, the snakes appear to move as the viewer's eyes drift over the image, even though the image is completely still. This illusion highlights how our brains try to predict motion based on the information at hand. Interestingly, these illusions also point to the possibility that our visual system might be tuned more towards spotting changes in our environment rather than providing a pixel-perfect static image of the world around us. This could be an evolutionary advantage, as changes often signal potential threats or opportunities. Impossible shapes are also illusions that trick our brain into perceiving three-dimensional objects that cannot possibly exist in our three-dimensional world. The Penrose triangle is a prime example of this. Our brain, being a pattern-seeking machine, naturally tries to interpret these impossible figures as it would any normal figure. It's only when you try to trace the object's layout that you realize something isn't quite right. The object cannot exist. It violates the rules of Euclidean geometry, bending and looping in ways that defy logic. But how does our brain even construct these impossible shapes in the first place? This brings us to the topic of visual processing in the brain. Visual processing is an intricate operation that starts in the retina, where light is converted into electrical signals. These signals travel along the optic nerve and split into two main pathways, one leading to the primary visual cortex in the occipital lobe at the back of the brain, the other diverging into several extrastriate areas. The primary visual cortex, also known as V1, handles basic visual information such as edges, colors, and the orientation of objects. It sends this information to the extrastriate areas where it's further processed. Two of these extrastriate areas, V2 and V3, are particularly interesting in the context of illusions. They specialize in processing complex shapes and integrating depth information, creating a cohesive image of the 3D world around us from the flat 2D images on our retinas. When confronted with impossible figures, these areas try to reconcile the conflicting depth cues and create a three-dimensional interpretation that is, well, impossible. Now, this doesn't mean our brain is flawed. On the contrary, it illustrates just how much our brain has evolved to help us navigate a three-dimensional world. It's optimized for efficiency and consistency, even when that means being momentarily tricked by an impossible figure. Our brain is hardwired to seek patterns and familiar shapes. It's why we see a man's face on the moon or a dragon in the clouds. This phenomenon, called pareidolia, demonstrates our brain's incredible ability to construct meaningful images out of randomness. In clinical settings, optical illusions have served as vital tools to understand conditions where perception is distorted. In conditions like schizophrenia and autism, individuals often exhibit a distinct response to optical illusions. For instance, individuals with autism are found to be less prone to certain illusions, such as the Ebbinghaus illusion, where two circles of the same size are surrounded by larger and smaller circles, making the same size circles appear different. What this suggests is that in autism, there might be a reduced influence of contextual information on perception. This tendency to perceive things in their factual, context-free state can help us understand the often remarked tendency of individuals with autism to focus more on details rather than the overall picture. In the case of schizophrenia, individuals are less susceptible to the hollow mask illusion. It's proposed that this reduced proneness could be due to an alteration in the way the brain processes social and facial information, which aligns with the social cognition impairments often seen in schizophrenia. Optical illusions don't just entertain us, they give us a window into the fascinating process of perception. They demonstrate that seeing is not just about passive reception of light by the eyes, but an active construction by the brain. While we may trust our eyes, our perception of reality is a grand illusion spun by the brain. From the spinning dancer that seems to change direction to the lines that appear longer or shorter than they are, every optical illusion is a testament to the wonders of our visual perception. They remind us of the simple truth: seeing isn't always believing. So with that, we would like to thank you for joining us, and if you found this video interesting or informative, please make sure to hit that like button and subscribe. And as always, stay curious, keep exploring, and let's dive into the mysteries of our universe together.